Okay, so just to quickly review or go over or talk about the stuff that I taught you yesterday, we talked about how logarithms and exponents are inverses of one another, right? We're all good with that? And what do we know about, although we're not graphing it, what do we know about the graph of inverses? What happens to them? Good. It's reflected over the y equals x line, so the diagonal line that's on a graph. So although we're not actually going to be graphing, I am going to refer to the graphs because I think that maybe it will help to get a picture. Like, we have enough past knowledge that I'm able to do that and it will hopefully make sense, or it'll bring back some stuff that we've already done. In order to find an inverse, just a reminder that it has to be a one-to-one function in order to find the inverse. If it isn't a one-to-one, then we restrict it to make it a one-to-one. We swap the x and the y. We talked about that yesterday. And then the graphs of the original f of x and its inverse are reflections over y equals x. That's what we just talked about. So we'll get rid of that. And then I'm going to zoom in on this for a minute. So this is what we were talking about yesterday. If we have our original y equals b to the x and we want to find the inverse of it, we would simply swap this and this. Good? This is literally exactly what we went through yesterday. The only one new thing that I'm going to highlight or go over here is this part. We didn't talk about the restrictions on our equations. So let's maybe take a look at that. Before we get to that, let's review a little bit. If we're looking at this part, log b of x equals y. So remember what I taught you yesterday, the tiny little b that's at the bottom in the logarithm, so the base of the logarithm, also is the base of the exponential form. And then the x and the y, we just swap them. So before b was with x, notice here now it's with y. And then the x is the one that ends up isolated on its own off to the side. Good? That's just basically review from yesterday. And then let's take a look at this part here. We have these restrictions. We know that our b value must be greater than 0. Our b value is not allowed to be equal to 1. Because if I plug in 1, what's my answer always going to be? It's always going to be 1. Does that make sense? Because of the nature of exponential functions. X is always greater than 0. And so these, I don't know how to say it or what to, I think as we go through and start to look at this, you'll start to understand the reason why these are there. But for now, I guess just know those or memorize them. And then as we get to working with these equations, you'll start to be able to make sense of and understand the reason that they're there. Good? And I briefly started to show you this yesterday, and then maybe we hit a point where it wasn't going so well. But now that we are a little bit familiar with this, with what a logarithm is and how to write it and how to change it to exponential form, the next thing here is that if we have log base 10 of x, we can just write that as log x. So we can just drop the 10, or you don't have to write the 10. If you see anything that just says log, like log 7 or log 5, if there's nothing written in the tiny little base at the bottom, the assumption is that the base is 10. So that's like the standard logarithmic form, I guess in its most basic form. Ian, can you do me a favor and close the door, please? Thank you. Too loud, I can't focus. Sometimes I play this game where I talk louder to see if I can make Mr. McPhee close his door, but I don't have the energy to do that right now. So we'll just close the door. Okay, are we good with that so far? So I think it's good maybe that I introduced you to this yesterday. So then let's start by warming up by doing a few of these questions. I'm going to get you to do these first 4 on your own. It truly is review from yesterday. And not to worry if you don't remember, don't get it. We're going to go through it together in just a minute. But do take a couple of minutes to try these, and then we'll go through them together. Does anybody need more time? Okay, so in the first one, what is going to be the base in my exponential form? 3. So that's the base, and then we just swap the other two. So 3 to the power of 3 equals 27. I've purposely chosen some values that I know that you for sure know the answer to. So looking at this, is this starting to kind of make sense? We know 3 to the 3 is 27. So then this helps us to sort of put logarithms into perspective. The next one, if the base of the log is 7, what's the base of the exponent? 7, and then we swap the other two. So we end up with this. Good? Another one that you know for sure. So it's nice to use those. If you ever, I would suggest, happen to forget in a quiz or a test or while you're doing your work, choose something that you know for sure and use that to help remind you. Does that make sense? That's a good strategy to use. For part C, the base is going to be 4. I feel like you've all got this. 4 to the negative 3 is 1 over 64. Are we all good with that? Just a reminder. So yes, this is how it looks right now, but we know that this is like saying, I'm just going to do this off to the side, 1 over 4 to the 3 to make that negative exponent positive. Good? Just some review, and that helps us to understand where the 1 over 64 comes from. And then for the last one, I purposely chose some that were a little bit different or unique. If there's nothing written there, what's the base of my exponent? 10 to the negative 4 equals 1 over 10,000. Make sense? It's like saying 1 over 10 to the 4, which truly is this value. Good? Okay, so I think yesterday it was the combination of, no, I don't know what it was. Maybe it's just because it was brand new or it's a new concept, but you all... Yeah, something weird was up yesterday, but but I feel good now. Do you feel good about this now? Okay, good. Yesterday you looked like traumatized, like I had scarred you for life, but you're okay today? Okay, good. So now let's take a look at these. Change from exponential to log form. Again, I'm going to give you a minute because I think it's helpful if you practice it yourselves. Because to sit there and to watch me do it, it's easier to say, oh yeah, I get it, but it's when you try it yourself that you actually are able to see if you truly got it or not. So right now, I just want you to do A and B. Don't worry about the others. We'll get to those in a second. But are we done with A and B then? Okay, so for A, obviously I need to write log. What's the base of my logarithm? 4. And then what goes with it here? What are we taking the logarithm of? 1, and that's equal to 0. So here's where the mind shift, like where this comes into play. I feel like it this way, is this a little bit harder to wrap your head around? Or is it starting to kind of, okay, so how about the next one? Log, what's going to be the base? And what are we taking the log of? 1 over 25, and that's going to equal -2. So here's the thing. You are going to be tempted to avoid logarithms as much as you can, and you're going to keep shifting things to exponential form. That's okay for the first little while, but I eventually want you to get to the point where you're as comfortable with logarithms as you are with exponents. Because you might not remember it now, but the first time you learned about exponents, you probably looked exactly like you did yesterday. Because that was a big mind shift as well, way back then, like maybe grade 8 or grade 9. So don't avoid logarithms. If you keep changing everything to exponential form and then have to change it back to log form as you're working your way through the questions, you're going to run out of time. Does that make sense? That's an inefficient way where you're not truly learning the skills. You're just avoiding, like, yeah, I did teach you about living in denial for a bit, but not forever. You just do that as a temporary tool to get you through until you're able to understand, and then you bring back the logarithms. Good? Okay, so determine the numerical value of the following. Let's go through the first one together, and then I'll let you do the next 3 on your own. So because this kind of resembles what we've done, but there's a little bit to it that's a bit different. We want to figure out what x is. We sort of have an idea based on these ones that we just looked at of what it might be, but I want you to work your way through this so that you can tell for sure. So just by looking at this, we can change this to exponential form. Can you tell me what it's going to be in exponential form? 9 to the power of x equals 27. Everybody good with that? Okay, I don't actually want you to go through this. We're only doing this temporarily to get you to wrap your head around what this is and to fully understand it. Ideally, what we would like is, well, kind of like if I gave you like 5 squared, you'd all be able to just spit out the answer. You wouldn't have to sit there and go 5 times 5, like you just know it, right? Similarly, I would like to get us to a point where you just know log 9 of 27, which you might right now, but let's do this together anyhow. Yesterday we went through how to rewrite these looking for similarities. So how can we rewrite 9 and 27? What do they have in common? A base of 3. So we can say 3 squared, well that's not, oh that is squared. 3 squared times x equals 3 cubed. Everybody good with that? Okay. So then if we work our way through this, what would be the next step in order to solve this? Yeah, so we're kind of pretending that we're getting rid of the bases, but we talked yesterday about how that's not actually a real thing, but we can use that rule number 8 from yesterday to help us to work our way through this. And then do you see that x just ends up being 3 over 2? Good? And you also could take that, of course, and plug it back in here to check to see, like, does that make sense? Right? And if we have a fraction of 3 over 2, we could plug it in for x. Let's take a look at part B. Well, actually, try B, C, and D on your own. Good? Another minute is good, or do we need a bit more time? Minute? Okay. Okay, I think, are we good to go? Okay, so how do I set this up for part B? 25 to the x equals 125. Are we like very comfortable with this now? We've done this and practiced it a few times. And then again, look at the similarities. How can we rewrite this using the similarities? Yeah, 5 to the power of 2x equals 5 to the power of 3. It's actually looking almost identical to the last one, right? So 2x equals 3. So what is our x value? It did just happen to work out to be exactly the same thing, but that works. Good? Okay, so then the next few have a little bit more going on. So if we have log base 4 of 0.25, what's my base? 4. What's going to be the exponent? X. And that equals, I mean, I don't really, let's change that. Instead of 0.25, what's going to make it easier for us to work with? Yeah, let's write a quarter, and then let's take it a step further. Right now, there's not a lot I can do with that. How can I rewrite a quarter that's going to make it easier for us to work with? 4 to the negative 1. Does that make sense to everybody? So do you see that, like, over the years, you've picked up all these different skills and different ways of rewriting the same number. So we're wanting to find the method that's going to make things easier for us. So we're basically always looking for similarities. So then what can I say? X is equal to negative 1 using that rule number 8 from yesterday. Good? Last one. For D, what's the base of my exponent? Root 3 to the power of equals X. Good? Is that it? Like, what did it say? Did it say simplify? Oh, well, it didn't, but that's not right. What can we do with this? I didn't quite hear, but I think you're saying the right things. How can I rewrite this? Like, this is saying square root of 3 to the power of 4. Emmy? Okay, so yeah, I am so glad that you just admit that. Not because you just said that, but because this is what I always do. I'm pretty sure I'm going to make the quiz non-calculator. And the reason is, I know, I'm sorry. And it's not at all because you just said that. It's because I want you to get, and this isn't me being mean, this is actually going to help you. I want you to understand the skill and to get like where that came from. So this is reviewing a little bit, but you know how we have square root of 3 to the power of 4? We learned way back how to write this without the root symbol. When you have square root of something, what is that the same thing as? Malcolm? To the power of 1/2. So if I already have a 4 there, do you see it's going to be 4 over 2? That is exactly the same thing, believe it or not, to what we had written up there. Is this kind of coming back? Like, you probably haven't done that for a year or two. I don't know. Depends on what happened last year. So after all of that, so Emmy, does that make sense? So we're going to look at, I want to teach you that you're smarter than your calculator. Good? We don't even need calculators. We're good. So 4 over 2 is the same thing as just 3 squared equals X, right? And then that's how the calculator is spitting out a 9. This is the same reason why I could teach the whole course, and some people do, using graphing calculators, and there's nothing at all wrong with that. I don't know, there's something in me that just can't, like, I'm okay with you using the graphing calculators or the technology once you understand the basics, but I do think it's important and it's going to help you if you understand the basics, because do you see that each year or each unit we build on the basics? So if that's missing, I feel like I'm kind of setting you up for failure. Good? But once you know how to do the stuff, if you then want to use graphing calculators or technology to speed it up, I have no problem with that. Good? Okay, so that's a lot. So then you know how this goes. I taught you the very simplified basic form, and then we start adding stuff to it. So let's take a look at, well, first of all, this is pretty complex. Before we just had a simple little number here, simple little number here, and now there's a bunch of stuff going on there, right? But no big deal. If we are looking for the domain of this, well, let me take it back to the form that I first showed this to you in, and that was log little base b of a. And we didn't do a whole lot of stuff with this. So I'm going to repeat what the restrictions were, or what I had mentioned at the top for, yeah, I guess just the restrictions. But we talked about how a must be greater than 0. So that's, Look at me, I'm getting lazy. I'm not color coding things anymore. I'll fix it for you. So a from there must be greater than 0. The b that's there must be greater than 0. And b is not allowed to be equal to 1. So I had showed you this because we had compared it to exponential form, and we talked about how b, if it was equal to 1, the answer would always be 1, right? So you really have to know these restrictions, and now that we know these restrictions, we're just trying to apply them to this scenario. I'm going to give you a minute or two. I haven't taught you this, but you have a brain. And we have all of the stuff that led up to this, so I feel like you can maybe figure this out without us going through it together. We'll go through the solution in a couple of minutes, but just see if you can work your way through that. If it's asking you about the domain, see if you can think of, in this specific example, what x is not allowed to be, what it is allowed to be, however that makes sense to you in your mind. And if you're so confused, don't worry about it. We're going to go through it together. Okay, so if we take a look at I like to do this often, go back to the basic. So this is the basic form of the equation. And what I want to start by asking you is what is the b in our actual question? X minus 1, okay. So that's like the b value. So I want to look at the restrictions on b and I want to apply them to that x minus 1. Right? So it's sort of just like translating or picking out the stuff that you need and figuring out which part it goes with. So I guess we can start with that. Well, I'm going to do it under here. So do you see that x minus 1 must be greater than 0? Is a good place to start because that's this part here. So then what does that mean? X must be greater than 1. So there's one part of our restriction. Actually, at the same time, I'm going to draw a number line so we can start to, oh, what am I doing? 0. I don't know what's happening. I was thinking ahead. I was drawing the open circle, but I missed the line. What's the big deal? Okay, so in the next part, b is not allowed to be equal to 1. So x minus 1 is not allowed to be equal to 1. Does that make sense? That's me referring to that part there. But instead of b, we're plugging in the x minus 1. Good? So then if we work our way through this, what is x not allowed to be? We just move that over. So x is not allowed to be 2. So I'm going to draw an open circle at 2 because remember, if it is allowed to be we color in the circle. If it's not, then we leave it open. That's what that means, or how we translate it. And then for the other part here, when we look at a, what's a in our equation? X plus 2. So we would just take that x plus 2. This isn't thick enough. Let's change that. X plus 2 has to be greater than 0. So x has to be greater than -2. So I would go -1, -2. Greater than, it's not greater than or equal to, so I leave an open circle. So then here's how we decide which part of this makes the cut for the domain, because there's a lot of things happening here. Like, I'll draw it sort of lightly at first so that we can kind of make sense of this. It's saying x is greater than 1, so that would be to the right, but it's not allowed to be 2, so it would go like this, right? But then the other part of it says, why do I try to color code all this? I feel like that helps you, does it, to understand stuff? Okay, good. Or I'm thinking, am I just wasting my time doing all this? It's very stressful, the colors. So the other part says x is greater than -2. So maybe to show you, I'm going to do this below. You wouldn't really do this in real life. I'm just trying to teach you the concept and showing you that I could do this with the purple, starting at -2. What's wrong? Oh, just that this part here would start at -2. Yeah, and it would go all the way, like, basically to the right of -2, right? So then to truly make sense of this, we'll use, I don't know. See what I mean with the color? Okay, I'm gonna use yellow. We want to choose the most restrictive part. Do you get what I mean by that? So what I was hoping to do with these colors is show you the overlap. We need to pick the part that overlaps. Does that make sense? So even though it starts back here at x is greater than -2, but then that doesn't satisfy all the green part here. So I'm not going to use that. I need to go to the most restrictive part, and I need to start there. So actually, when I go to give my answer, I would start at -1. I would go greater than -1. +1, and I would go to the right. So x is greater than 1, but not allowed to be equal to 2. So actually, this is, although the purple portion is a part of like the steps to get there, we wouldn't include it because it's not overlapping. Does that make sense? So I don't know that you have to actually spend all this time coloring and overlapping and whatever, but I wanted to make sure that you get the concept. Does that make sense? Questions about anything? What I'm realizing watching my videos back to myself is that I say, does that make sense? Over and over again, all class long. Yeah, okay. No questions? We're good to move on? Okay, we are skipping this, and we're moving on to inverses. I know it's kind of a good feeling to just put a big X over. Maybe we'll come back to it eventually, but we don't have time for that stuff right now. Let me explain that to you. We skipped the exponential graphs and the logarithmic graphs. When we go through stuff, the algebra and the graphs are the same thing. The algebra is working our way through it, will give us a more precise and accurate answer. The graphs, the way that I view it, is a tool for us to be able to visualize or picture what it looks like. So I'm focusing on the algebra That's the part you're actually going to use. But maybe I will just show you the graphs, like you know how we briefly talked about it last day, so that you can get a mental picture of what it's like. Good? Okay, so taking a look at inverses of exponential and log functions, let's go through some examples of this. We've already talked about this. We actually did this right at the start. So if y equals b to the x, then the inverse would be x equals b to the y, and we would work our way through the algebra to get the y by itself, right? So that would end up looking like this. Y equals log base b of x. Now that we've practiced it a bit, does that make sense? So that would be like a step along the way. And then when we isolate the y, the b ends up being the little b in the base of the logarithm, and we would swap the x and the y. So are we all clear on, maybe I'll show it this way? That would be a step along the way. When we isolate our y from this, we'd have to change it to log form. And this box at the end ends up being our end result for the inverse function. Good? Okay, so without all of those steps in between, this would have been very confusing, but I feel like, are we at the point where we're kind of getting this? You're not rejecting this? You're okay with it? Good. So then if the point 6, 3 is on the graph of y equals b to the x, what point is on y equals log b of x? Yeah, it's not a trick question. It would be 3, 6. If they're inverses of one another, we simply swap them. Good? Okay, so then that's just I wanted to make sure that I at least talk about it or go over it, but let's actually work with this. Determine the inverse of this equation. F of x equals 3 to the power of x plus 1, all plus 5. I'm going to give you a couple of minutes. I feel like you can do this. Good? So I'll give you a few minutes, then we'll go through it together. Remember the steps. We swap the x and the y. We isolate for y, for the new y. The inverse, I want just the inverse. So if this is an exponential, the inverse must be in log form, right? Yeah. Sorry, you guys, I'm going to change this. This last equation should be x equals log b of y. That makes more sense. Right? In order for them to be... No. 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 Sorry. Because it's asking for the inverse. Got it. I do. Am I weird?
I could tell Chopin on piano.
You play that when,
No,
or sorry, you listen to it while
I
you're
kept
working?
listening to it.
Nice. How this all started is last year I had my prep block first thing in the morning.
Right.
So I'd listen to this calming music while I was doing my work. Yeah, and then the next class came in. It was a grade 12 class as well. And one day I forgot to turn it off when they came in and it was playing. And they started asking me, like, Miss Baines, what is that? And I told them, and they said, can we listen to it while you're teaching? And I thought, sure, why not? So we tried it for a day, and then they started asking for it each day. They liked it, so then I started doing that in all my classes. Yeah, I do think that it makes a difference whether you're aware of it or not. It's like doing math at the spa, you know? Yeah. So I almost always, I love music. Like, not always this, I just love all types of music. So whether I'm cooking, clean, like whatever I'm doing, I like to listen to music. So why not bring it into class, right? And hopefully it'll start to work properly in the videos and not be too loud, but. Okay, I should stop talking to you and let you do your work, or are you done? Are you done? Okay. So the first step is we would change this to y equals 3 to the x plus 1 plus 5, right? So rewrite it with a y. We would swap the x and the y. So we'd have x equals 3 to the y plus 1, all plus 5. And then we would want to, I'm going to zoom in here because I'm assuming you all have that down already. Our goal is to get y by itself, right? So let's move the 5 over. So x minus 5 equals 3 to the y plus 1. So don't let this part throw you off. It has a bit more going on than the other examples we had. I could put brackets there. I don't really need them, but I feel like for whatever reason that helps people to keep track of things. What could I do to this? Like, if my variable is up top in the exponent, what's my only option in order to work my way towards solving this? Emmy? Put it into log form. Yeah, so if we change it into log form, what's the base going to be of the log? The little base is going to be log 3, so we got that from there. And then what am I taking the log of? X minus 5. So do you see that we're swapping these two? Does everybody see that? And that's all going to be equal to y plus 1. Like, okay, so remember what I said on the first day? On the first day. Was that yesterday? Yeah. Oh. See how crazy this all is? That was yesterday. This looks kind of intense, but because we're going through it step by step, I hope you're finding it's not too bad. I want y by itself, so do you see that I would just subtract that 1? So y equals log base 3 of x minus 5. So that, I want you to look at it this way. It's like this thing is stuck together as one unit. So you can't have the log, like, I'm going to take away 1 at the end, but I can't just attach that minus 1 to this minus 5. Does that make sense to everybody? I guess it's similar to when we have something like 2 to the power of y or something. You can't separate the 2 and the y. I told you yesterday, like, the y is needy. They need to be attached together. Similarly, it's like one unit. If you're taking the log of something, it's stuck with that log. You can't just, it's not like a like term with this minus 1. Good? So after all of that, I do want to point this out, and it's not me being nitpicky. Many of you did not do this on your polynomials test, or what would it have been? I don't remember. But we need to make sure that we write maybe the transformations test, whenever it was. We need to make sure that we use the proper notation to show that this is our inverse. So take the extra second to write it out appropriately at the end. And so that would be our result. Let's go back to what we started with. So yeah, it's kind of intense. There's a lot of things happening, but if we go through it step by step and use that approach, hopefully it doesn't feel quite as overwhelming. Good? This stuff has a horrible reputation. Aren't you feeling pretty good about it so far? Not so bad. So that's true of everything. If we break it down into smaller parts and then put it together, it won't be so bad. Isaac? How do we write the answer in exponent form? This is the exponent form. Like, so this is the inverse in log form. You mean you want this in exponent form?
The inverse in exponent form.
Oh, would be 3. Oh, you would have to have 3 to the power of y minus 1 equals x minus 5. You'd have to, or sorry, y plus 1. You'd have to move this 1 over to the other side.
It's not relevant right now.
It's not at all. No. Just being honest. We can talk after and I can show you if you like. Good? Are we all good? You know how this goes. That's how you, ew, really? It's not that bad. You're just doing...
I just didn't even look at it. I was like, eh.
Yeah, it's the same thing, but the other way around. And that's, it feels painful, but that's how you really understand it, is if you can go in a circle, so go forwards, and then come back around the other way, that's when you truly get it. So I'm going to give you a couple of minutes.
3 or 5?
At the bottom?
Yeah, the last number.
Oh, this is a 5. Yeah.
Yes. Oh.
Okay, so we'd have y equals log 3, x plus 2 minus 5. And then we would swap the x and the y. So x equals log base 3 of y plus 2 minus 5. Our goal now is to try to get this y all by itself. And so we work our way through the algebra. Do you see that I'm going to add 5? So I'd have x plus 5 to get rid of it here equals log base 3 of y plus 2. I don't really need to do this, but I'm going to just to make it clear and obvious that they're kind of stuck together and move as a unit. Where do I go from here? I think this is the hardest or the most confusing part, maybe. Malcolm?
You change it to exponent form.
Yeah, change it to exponent form. So what is now going to be the base? The base of the exponent is 3. What is going to become the exponent? To the power of x plus 5. The brackets don't really need to be there, but I don't know. I feel like people leave behind a number or like weird things happen. So if you do that, I think it just helps in terms of organization. What is the whole thing equal to? Y plus 2. Everybody good with making that switch even when we have this much stuff going on? That is progress. Remember when yesterday, way back yesterday, just with the little numbers, we were having a hard time, and now look at what you're doing. That is progress in 24 hours. Okay, we're not quite done. We want to get rid of this 2, so we'd have y. Actually, let's just write it properly right now. We know it's the inverse, so let's use the proper notation. It'd be 3 to the x plus 5. So if you want, you could write it like that. Just make it very obvious, though, that it's the little exponent if you're not going to put the brackets. And then subtract 2 from the whole thing. Yes?
I don't think that's it, though. I changed it to exponent form a little earlier.
Yeah, no problem. So again, stick with, there's lots of different ways of doing it. Stick with whatever works for you. Good? Harrison?
Yes. Oh, goodness. Sorry, come back to me. I
Okay,
lost it.
no problem. We're done. So 5.2, numbers 1 to 5, you can do the odd letters. This is just my suggestion. You decide. If you're struggling with this, you feel like you could use more practice, don't just do the odd letters, do more of them for more practice. Good? And if you've really got it and you feel like it's repetitive and redundant, you could do less. So you decide. You're old enough to be able to decide that. 8, 9, and then 13 AC.